Welcome back to part 3 of this walking talking mock, which is Further Maths, paper 2, June 2015. And we're on question 18. And I just had a look at the examiner's report, and it says that question 18 was poorly answered. So this must be a difficult question. The sketch shows the quadratic curve, which is in a completed square kind of format. The curve passes through 0, 10 and 2, 10. Give reasons why the value of A is 1. Okay, if something's in a completed square format, it tells us the minimum point, or the vertex, which is this thing here. So I can see from this that the minimum point is going to be A, B. So that is A, B. And looking at the picture, I mean, this is symmetrical, right? If that's 0, 10 and that's 2, 10, then the thing that is directly in the middle is going to be 1. The line of symmetry is going to be x equals 1. So A must be 1. So how to explain that? I'm going to say the vertex is AB by symmetry. I can't just say by symmetry A equals 1. I mean, is that a bit too obvious? By symmetry, A is, I'll put the middle of 0 and 2, which is 1. Hopefully that's convincing enough. I wonder what the math scheme says. Hang on a sec. Question 18. Sorry, I'm still scrolling. (16, 17, 18). Right, okay. Oh, okay, yeah. All you have to say is it's symmetrical about x equals 1, or the minimum point is when x equals 1, or it's midway between 0 and 2. Okay, so yeah, that's fine. Don't have to say much. Okay, better keep that. Part B, work out the value of B. Where's B? Okay. So I know the x coordinate is 1. So I could put A into that. I could say 4x minus 1 squared plus B. I suppose what I could do is I could use the fact that 10 is the y-intercept. If I expand this out, okay, so I can see that the constant bit, the bit that doesn't have x in, is 4 plus b. So 4 plus b would have to equal 10, because the y-intercept is 10. And the bit that would be the y-intercept is 4 plus b. So that means b is 6. Write the equation in that form. Okay, well, that's easy. I've almost done that. That makes me think I did the previous part in a way they weren't expecting. Let me look at the mark scheme, see how they did B. Oh, okay. They substituted 0 and 10 into the equation, which is pretty much the same as what I did, but I did it with expanding. Okay, use the factor theorem to show that x minus 3 is not a factor. Right, factor theorem says that if that is a factor, then the opposite thingy must be a root, which is, the opposite of this would be 3. So if I put 3 into the equation, to show that it's not a factor, I'd have to show that the answer is not 0. Because if it was 0, that would prove that 3 is a root, which proves that x minus 3 is a factor. Didn't see that. Okay, which is not equal to 0, therefore not a factor. I just realised that's a different question. I thought this was still the same question. The transformation matrix P represents a 90-degree anticlockwise rotation about the origin. Describe fully the single transformation represented by the matrix P cubed. Ooh. Okay. P cubed. There's two ways of doing this, okay? There's a long way and there's a short way. The long way would be to work out what the matrix would be in terms of the 4 numbers, and then cube it, so times it by itself, and then times that by itself again. And then work out what transformation that would be. But the much faster way of doing it would be to realise that P cubed means do the transformation 3 times. So if you rotate something 90 degrees anti-clockwise 3 times, what happens? 1, 2, 3. So that's the same as rotating 90 degrees clockwise, isn't it? Or 270 degrees anti-clockwise, whichever you want to say. So rotation clockwise 90 degrees about the origin. The transformation matrix Q is that, transformation matrix R is that. Describe fully the single transformation represented by the matrix QR. Okay, QR means that, by the matrix QR, as in Q times R, okay, which actually means, it's the other way around from what you think. It means R first, then Q. It's kind of like functions, okay? With functions, when you have like fg of x, it means you do g of x first, and then you do f of the answer. Same with matrices, so it means you do the transformation R first, and then you do the transformation Q. So, again, we could multiply these, and then work out what that transformation would be. Or we could interpret both of these as transformations, and then think about what would happen. I feel like multiplying though. So when you multiply a 2 by 2 matrix with a 2 by 2 matrix, your answer is going to be a 2 by 2 matrix as well. And we're going to do 1 times minus 1, which is minus 1, and 0 times 0, which is 0. So that's just minus 1. Okay, then next element we've got 1 times 0, which is 0. 0 times 1, which is 0 as well. So that's just 0. Then we've got 0 times minus 1, which is 0. And minus 1 times 0, which is 0. Then 0 times 0, which is 0. And minus 1 times 1, which is minus 1. So So that is the multiplication of those two matrices. Okay, now let's think of the transformation. So that column tells us that 1, 0 will be mapped to minus 1, 0. So the point 1, 0 will be mapped to minus 1, 0. So it's going to go over there. And this column tells us that 0, 1 will be mapped to 0, minus 1. So 0, 1 will go to 0, minus 1, go down there. Okay, so what would move that to there and that to there? Well, that's a rotation by 180 degrees, isn't it? Yeah, that's the only thing it can be. Yeah, it's the only thing it can be. So, rotation 180 degrees. I don't need to say clockwise or anti-clockwise because it makes no difference because it's 180. But I do need to say about the origin, even though matrices can only rotate things about the origin, I still have to say. Sorry. 21. A cubic curve has maximum point of that and a minimum point of that. The tangent to the curve at A and the normal to the curve at B intersect. Okay. Work out the area of triangle ABC. You may sketch a diagram to help you. Why, thank you for letting me sketch a diagram. I think I'm going to use pencil, just because I'm kind of worried I'm going to draw it wrong and then I'm going to mess it all up. Maximum point minus 4, 10. Let's put that on. Minimum point at 2, minus 26. So that's A, and that's B. We don't know where it goes through, so I'm going to do something like that. The tangent to the curve at A, which is going to be horizontal because A is a maximum point, which means that the gradient is 0. The normal to the curve at B, okay, which is going to be vertical because the tangent would be horizontal, so it's perpendicular to that. So I know this is right angle. Intersect at point C, so that is C. Work out the area of triangle ABC. Okay. I suppose I need to find the coordinates of C, don't I? So how should I do that? Shall I find... Okay. Well, actually, that's really easy. The y coordinate of C is obviously 10. And the x coordinate of C is obviously 2. Make that line up a bit better. So that's just 210. Okay. So this length from here to here is going to be minus 4 to 2, which is 6. And this length is going to be from minus 26 to 10, which is 36. So the area is half times 6 times 36, which is 108. It wasn't as bad as I thought. (22) A quadratic sequence starts like that. Work out an expression for the nth term. Okay, nice. From that to that is 298. That to that is 294. That to that is probably 292. Oh, it's not. No, 290. Yeah, because they're going down in fours, isn't it? Okay, so because the second difference is minus 4, that tells me it's going to be minus 2, because I halve it, n squared. So I'm going to write out our sequence. And I'm going to write out minus 2n squared. Which is, okay, 1 squared is 1, times minus 2 is minus 2. 2 squared is 4, times minus 2 is minus 8. 3 squared is 9, times minus 2 is minus 18. 4 squared is 16, times minus 2 is minus 32. And then I'm going to take away. (302) take away minus 2 is 306. 600 take away minus 8 is 608. 894 take away minus 18 is 912. And, you know what, I'm just going to use a calculator. 1216. This should be a linear equation, linear sequence. 302, 304, something's gone wrong. You probably already know what's gone wrong, because you've probably worked out. Ah. You probably spotted that, didn't you? Yeah, 302 plus 2 is 304, not 306. Embarrassing. Okay, so that's actually 302. Although, wait, that wasn't even the problem. Oh no. There we go. I just crossed out 2 and wrote 2 again. Okay, so now it's fixed. So the difference is 304, which means that is 304n. And it starts from 304, so it's actually just the 304 times table, which means we don't need to add a constant on the end, it's just fine as it is. So it's that. Okay, a term in the sequence has value 0, find the position of this term. Okay, it's going to be a negative position, isn't it? Because look, if the sequence starts at 302 and it's just getting bigger, it's going to be a negative term. Fair enough. So, if it has value 0, then that must equal 0. So, actually, you know what? It's going to be the one before it, isn't it? Because if you carry that sequence on, that would have to be 302, which would mean that that is 0. So it's the 0th term, isn't it? The 0th term. I was going to solve this. Oh, you know what? I may as well solve it anyway. Let's take 2n out as a factor. So n equals 0 or n equals 152. Well, that doesn't make sense. When n is 152, it's going to equal 0 again. How? Is it going to... Oh, will this sequence like start to get smaller again? That makes sense, because quadratics, you know, quadratics are like... this is a negative one, isn't it? So it's going to be something like that. So it's going to get bigger and bigger and then smaller and smaller. It says a term in the sequence. I guess because the 0th term isn't technically a term, is it? Because it's the first term onwards is the real sequence. Yeah, I mean it says a quadratic sequence starts like this, so you can't really have anything before it starts. That's not really... So I don't think you're allowed to say the 0th term. Well, I can just check the mark scheme. How about that? What question is this? 22. Scroll, scroll. It just says 152. It doesn't say 0. Let me read the examiner's report. Well, it just says part B was very poorly answered with many non-attempts. Okay, so I guess no one even thought it was going to be 0. Never mind. Right, let's see. Let's squeeze in one more question. The continuous curve y equals f of x has exactly 2 stationary points. P is a maximum when x equals a. Q is a stationary point of inflection when x equals b. Remember, that's one of those ones that looks like that. Or it could look like that. A is less than b. Okay. So there's a maximum, and then there's an inflection. So it's going to have to look like that, isn't it? A maximum, and then an inflection. Because it says A is less than B, so A has to be on the left. Okay, which of these is correct? When x is between A and B, dy by dx is positive. No, it's negative. Isn't it? Look. That's definitely negative. Okay. So I can ignore that one. And I can ignore that one. Okay. So when x is between A and B, it's negative, okay. And when x is greater than B, right, when x is greater than B, it's negative. So it's this one. And I know all of that from drawing the curve there, or sketching it. Okay, what part was this? Was this part 2? Part 3? I don't know, but I'll see you on the next part anyway.